Welcome, everybody. Welcome. I'm Ian Stewart. I'm co-director of the Centre for Climate Change and Sustainability alongside Professor Gautam Menon, and I'm delighted to be introducing today the second of our talks really within the 3CS sequence. So 3CS, just to say a few words, I'll mention more our speaker in just a second, but the 3CS, as many of you know, but is one of a number of research centres here at Ashoka University, but perhaps the most diverse in terms of the departments and backgrounds that it engages with. 3CS has members from English and history, psychology and media, biology, physics, economics, environmental science, creative writing and computer science. So it's a real blending, a real mixing really of disciplines, all of them connected by a shared concern for our planet and its pressing societal concerns. And it's committed to awareness raising, and we're going to hear I talk really on communication, and communication is one of those things that sits right at the heart of it. But also then advocacy and underpinned by research and being very much evidence-led on issues of climate change, issues of sustainability, sometimes ones that are global issues, but also issues that are particular relevance really to India. So in order to introduce today's speaker, I'm going to kind of hand over to Professor Mahesh, if you can take over, Mahesh, and just introduce Vandana. Thank you.
Thank you very much, Ian. It's a privilege to be here today. When Paul Gallico, later became a well-known novelist, interviewed Gene Tunney, who before he was to beat the world champion Jack Dempsey, Gene Tunney confessed that he read Shakespeare, and the piece was called "The Prize Fighter Who Reads Shakespeare." I was recalling this when reviewing the CV of our very distinguished speaker today. On the face of it, she has a BSc in physics from the University of Delhi, an MSc in physics from the University of Delhi, a PhD in particle physics from Louisiana University. She's a professor at Framingham State University in Massachusetts. But Dr. Vandana Singh is more than a physicist. She is a polymath. She is a writer of fantasy, children's books, science fiction. Among her other many works are The Woman Who Thought She Was a Planet, 2008, Ambiguity Machines, 2018, a collection of essays, and a book which really is apt for today, Utopias of the Third Kind, published by ETM Press in the very year 2022. Today's talk is titled Breaking Paradigms, Storing Climate Change. So over to the author, and a very warm welcome to you here at Ashoka, Dr. Vandana Singh. Over to you.
Thank you, Mahesh, and thank you, Ian. I am so thrilled to be among all of you, and so honored to be among all of you. So I'm going to go ahead and share my screen and start right away. So here goes. I'm going to put this on full screen, and please let me know if you cannot see it, or if there's any problem. Okay.
That looks good.
All right, thank you so much. So, breaking paradigms, storying climate change. I'm going to begin with a story. So this story I owe to the traditions of the Inupiaq people of Northern Alaska. And it goes like this. Once upon a time, there was a mouse who lived underground. And the mouse wanted to know the world. So the mouse made a tunnel and tunneled up, all the way to the surface of the tundra and emerged. And when he stretched his paws up, he could touch the ceiling of the world. When he stretched his paws sideways, he could touch the sides of the world. And he told himself, I am the biggest thing in creation. Now, the punchline of this story is that the mouse had actually come up inside the underside of an overturned boot. So the ceiling of the world was the sole of the boot, and the sides of the world were the sides of the shoe. So, this is a story from the Inupiaq peoples of Northern Alaska, and we'll come back to it in a moment. But I want to go on to quickly tell you a little bit about how I, trained in theoretical particle physics, ended up in climate education and through speculative fiction as well as through science. So I began about 12 years ago when I started to get really worried about the climate problem, and I taught myself enough climate science that I could teach it in my general physics college courses at my small liberal arts public university. And my intentions were basically ethical because I wanted to equip my students with the knowledge to understand the changes that were coming and also hopefully to be change makers. It turned out to be a very naive assumption because my first few attempts were failures. So I began by doing the usual things. I began by seeing how general physics courses and basic climate science intersect. So I taught the basic science in this manner. And I found that contrary to my expectations, students were discouraged, depressed, angry, and I was somehow sending them into paralyzing despair and anxiety. As you can see from some of the comments that I collected over the years, but not just that. It was not just that their affective response was disappointing. It was also that they had misconceptions about the climate problem. So that told me that teaching just the basic science was simply not enough, that I myself needed to become a student again, a student of the climate problem. So in other words, not just learn climate science from climate scientists, but also really think about what the climate problem was telling me, and therefore learn from communities as well. So among the key moments in my journey of learning, which is always ongoing, was a visit to Alaska in 2014, where I went to, as part of a program award from an institution in order to write a case study for undergraduate education on climate change. So here I am on the beach in a town called Utqiagvik, which is very close to, well inside the Arctic Circle and pretty much the northernmost point of the United States. Most of the people there are native peoples who have lived there for at least 4,000 years, and the rest of them are scientists and anthropologists and scholars. So you can see in the background the sea ice glittering, and I'm going to talk quite a bit about sea ice. So this is what I learned in that place. Now, before I get into my next story, I want to reorient ourselves so that we're looking at the Earth from the North Pole, with the North Pole at the center. And you can see that the Arctic Ocean is a liquid ocean. And we know there's a polar ice cap that has so far been permanent. And that is essentially frozen seawater. And that's what sea ice is. So in the winters, sea ice actually extends from the shores. And you can see here, if you can see my mouse, this is where I was standing in that photograph. So sea ice actually extends out from the shores for a few miles into the liquid Arctic Ocean. So my story has to do with, this was told to me, it's a true story. It was told to me by a geophysicist. And he said that when he went to the Arctic 30 years ago, to the Alaskan Arctic, he and a group of scientists wanted to study the sea ice. Now you can see here, this is sea ice actually that's attached to the shore. And you can see that it's quite thick. You can walk on it. In fact, sea ice thickness varies between a few centimeters to 4 to 5 meters for ordinary sea ice. So this group of scientists wanted to study sea ice. So they started to walk from the shore to the liquid water boundary. And they got to the liquid water boundary and they set up camp. And as they were setting out their instruments, the native elder who was with them said to them urgently, "You got to get off the ice right now." They looked at him in utter surprise because it was a perfect day. The sky was blue, the sea was calm, there were no warnings from the meteorological office. And yet there was so much urgency in his voice that even though they didn't believe him, they followed him reluctantly. They packed up and they followed him reluctantly back towards the shore. As they approached the shoreline, there was a thunderous, deafening crack, and the portion of the sea ice on which they had intended to camp broke off from the shore ice and floated off into the Arctic Ocean. Now, especially 30 years ago, and even now, if you are adrift on a piece of sea ice, that's a death sentence because you're subject to the unpredictable currents of the Arctic. And especially at that time, there was no Coast Guard presence, no rescue operations. So essentially, the elder had saved the lives of the scientist. And the scientist told me that he had thought that there was only one way to really learn about and know the sea ice. And that experience taught him that perhaps there are other ways. Now, when I share this story in the classroom, because in my freshman seminar on Arctic climate change, I start with story. When I share it, I ask the students, what are your questions about this story? What questions arise in your mind? Because that allows me to open up the context of the story. And the obvious question is this, that how did the elder know that the ice was going to break? And that leads us to a study of the relationship that indigenous people have had for millennia with the land and the ecosystem. It leads us to a study of the history of the Alaska Native tribes' struggle for land rights and the experience of settler colonialism. And as well as, trying to understand what is this thing called sea ice? And some of the other questions that arise include, why were the scientists there to study the sea ice? What's the big deal about sea ice? So that's when we bring in sea ice loss and the consequences, both local and planetary. So one of the things we know about the Arctic is that it is ground zero for climate change. And you can see on this graph, the decrease in sea ice extent since instrumental records for the region. And we also know that Arctic temperatures are rising 3 times as fast as the global average. So what are the consequences of all of this? This is what I get to explore once I introduce the story, and through discussion, we round out the context. Well, this is a very interesting poster that I encountered when I entered my little motel lobby during my visit in 2014. It was an alert for polar bears because polar bears had been seen in the streets of Utqiagvik. Now, Utqiagvik is really isolated. Like I said, you can't go any further north than that in the United States. And you cannot get to Utqiagvik by road. You can only get there by air. So the animals in the region, I'm going to talk briefly about 2 large mammals, the polar bears and the bowhead whale. So why are the polar bears coming into town? Well, because they're hungry. So certain populations of polar bears, not all, but some of them, are actually suffering weight loss. And they're coming into towns and settlements to look for, in rubbish bins for food. Why is that happening? Well, as sea ice retreats, seals, which are the main food of polar bears, they build their dens in the sea ice. Seals are also disappearing. And when seals go away, then polar bears have to hunt for food. And unusually for a bear, polar bears actually have a high metabolic rate. So they need to find food rather quickly in order to keep their metabolism. And so where there's metabolic imbalance, polar bears are suffering from weight loss in certain populations, and they're coming into towns and looking for food. So you can see that there's an ecosystem consequence to the loss of sea ice. And another consequence has to do with the bowhead whale. The bowhead whale is an enormous, large mammal that spends all of its life in the Arctic, swimming under the sea ice. They have a sophisticated communication system. They're very intelligent, and they live at least 250 years. So the bowhead whale is sacred to the Inupiat. They consider themselves the people of the whale, because in the harsh winters, when there's no other fresh source of food, the only way they can feed themselves is through hunting. They hunt seal, they hunt other animals, but most of all, they hunt the bowhead whale. The bowhead whale was driven to extinction, nearly to extinction, through Yankee whalers in the 1800s and 1900s, early 1900s, until there was a ban on whaling. But there is a quota that allows native peoples to hunt a certain number every season. And so here you see a whale, the carcass being butchered on the sea ice. The sea ice actually allows the native peoples to walk towards where the whales pass during their migration. And so they allow access to the whales. And it also allows a platform for the whale carcass to be dragged back. Now, the whales are sacred to the Inupiat. They believe that the whale gives its life to the people, to the hunters, in order that the people can continue to be Inupiat peoples. And therefore, the first thing they do when they hunt the whale is to thank it for the sacrifice of its life. The whale meat is never sold. It can only be shared. This is one of the few communitarian activities that is still extant despite the commercialization and modernization of Inupiaq lifestyles, in the sense that their economy is now part of the mainstream US economy in many ways. So the whale is necessary for survival, particularly in the winters, and the whale is also necessary for the identity of the Inupiat. The best analogy I can think of in terms of the sea ice, because the sea ice connects to subsistence hunting, particularly of the whale, is the way that Indians think of the monsoons as a matter of survival and culture. So the Inupiat think of the sea ice as a matter of survival and culture. So the picture below is of a region, a promontory in Alaska, in northern Alaska, called Point Hope, where it's not really clear in this picture, but it is there's a massive amount of coastal erosion taking place. So the loss of sea ice has meant, along with the rise of sea levels due to climate change, that Arctic storms can now devastate the coast. And along with that, and along with another impact of Arctic warming, which is the thawing of the permafrost being the mixture of frozen soil and water that is permanently frozen or was permanently frozen until recent times. So what that has done is exacerbated coastal erosions, and it's caused the collapse of a place called Old Town, which is on Point Hope, and it's an ancient native settlement. You can see here one of the old sod houses, which is built with whale bones. In fact, that entire promontory, the creation story of that promontory is basically a creation story of a whale that gave up its life so that the Inupiaq peoples of the region could have land on which to live. So the loss of Old Town, and the Old Town actually has been, there's a new settlement has been built by the government for the people displaced from Old Town, which is called New Town. And that consists of nuclear family homes with grid-like streets. And although there are many conveniences, which are not to be sneered at, however, the loss of culture and identity through the destruction of Old Town means a lot to the peoples of that region. And so now they're telling stories about it. And if I had time, I would talk more about the kinds of stories they're telling, the elders are telling to their descendants about Old Town. So one of the important aspects of the sea ice retreating and the permafrost thawing, then we can see two of the important aspects that I've talked about. Is one is that sea ice loss and permanent permafrost thaw threaten Inupiaq culture and well-being through all these impacts. They also cause major shifts in the ecosystems because the underside of the sea ice is the basis for the food chain because of algal growths. And everything from the fish to the seals to the polar bears to the humans ultimately depend on the sea ice for that reason, which I'm not going to go into the details. But nevertheless, we can see that that local ecosystem as well as the culture is threatened. But you might ask me, why should we worry about what's happening in the remote Arctic to the peoples and the ecosystem? What has that got to do with us here in India? We have a lot of other problems to think about. Well, it turns out that what happens in the Arctic doesn't stay in the Arctic. The Arctic is both impacted by and impacts the global climate system. And it does so in, broadly speaking, two ways. One of the ways is, of course, when permafrost thaws as a result of global climate change. It also, due to increased microbial activity, starts to become an emitter of carbon dioxide and methane. So it goes from being a carbon sink to a carbon source. And that's what we fear is happening. And then, of course, the other aspect is that everywhere in the cryosphere, the shiny regions of the globe where you have ice and, on glaciers, in the great ice sheets, on sea ice, all of these collectively reflect 30% of the sun's energy back into space without absorption into the Earth system. And therefore, they limit how much of the sun's energy is actually absorbed and retained in the Earth system. So as the cryosphere melts, that has a consequence because more of the sun's energy is then retained within the Earth. And that causes global heating. So in order to understand some of the wider planetary scale consequences, let's just look at some of these large scale processes for a moment. So as we know, the carbon cycle is a cycle in which carbon circulates through multiple Earth systems. There are processes that add carbon dioxide to the atmosphere, processes that take out carbon dioxide from the atmosphere. So carbon sources, carbon sinks. And when the two are acting at the same rate, at the same speed, then the amount of carbon dioxide in the atmosphere stays roughly level. and we have a kind of steady state, which I'm calling balance. Now that has been disturbed because we're adding new carbon sources by burning coal, oil, natural gas, and we are undermining carbon sinks by removing natural ecosystems and disturbing natural ecosystems from the tundra to forests to grasslands and so on, which are also carbon sinks. So the consequence of this imbalance in the carbon cycle leads to increased and increasing concentration of carbon dioxide in the atmosphere. And we know that carbon dioxide is a heat trapping gas. So what that essentially does is to create an imbalance in the Earth's energy system so that the Earth is not able to emit energy in the form of low frequency heat waves back into space at the same speed as it receives energy from the sun, allowing energy to accumulate in the Earth's system, therefore increasing temperature. And that is the key reason why sea ice is melting in the Arctic. But also we know the reverse is true. So in order to understand the consequences, I'm going to tell you another story. And this story takes us around the world to something much closer to home, which is the state of Jharkhand in India, one of the most climate vulnerable places in India, which is already one of the most climate vulnerable places in the world. The reason why Jharkhand is climate vulnerable is because of its impoverishment and also because of the fact that climate projections for the region are quite dire. So for example, projections include dreadful heat waves and also rainfall variability, which is always bad news for agriculture, for food and water security. So this story is a story of a group of women in an impoverished village next to a forest. And to give you the context, much of the surrounding contiguous forest had been cut down over the years. And the story starts about 20 years ago when Parvati Devi, the woman in the red and white sari, and her compatriots in the village realized that with the water table sinking, the groundwater levels going down, agricultural productivity was going away, and they survived through subsistence agriculture. So they got together and they decided to protect their dwindling 200 hectares of remaining forest. Now, in the broader context is, you might ask, why were the forests disappearing? Well, they were disappearing because of massive quarrying and mining and road building and so-called development projects. So this remaining forest was protected, was starting to be protected by these women 20 years ago. They would, every early morning, they would go out into the forest and patrol it. They would confront would-be loggers, an often dangerous task. They dug ponds inside the forest so that animals could have water to drink. And they made mud and stone check dams to prevent the streams from leaving the forest and evaporating in the desertified countryside. And over 20 years, as attested by a friend who visited there in 2019, through whom I was able to talk to Parvati Devi, the forest has recovered. The trees have become thicker. And many of the animals have returned, although Parvati ji told me that the tigers have not come back. So this story, and they continue their work today. And when I asked her what is it that motivates her, she said she's doing this work for her community and for the animals and birds. So this is a rather different kind of story than the ones I've told you before. And it's very different from the scientist and elder story. For one thing, the threat to this community is not directly due to climate change, at least not yet. It's in fact due to a very destructive model of development, and a model that is also extremely unequal. So we're going to come back to this, and we're going to see how this teaches us about climate change. But the point I want to make here is that although these two regions seem remote and unconnected, there are actual teleconnections between them. So because of the fact that what happens in the Arctic doesn't stay in the Arctic, but through complex causal connections ripples through the rest of the globe. As forests are cut down in tropical regions, which undermines carbon sinks, which helps melt more ice in the Arctic. The retreat of the ice itself, due to the ice albedo effect and other effects that are still being quantified, actually has the potential of warming the climate further. all around the globe, and therefore having a part in the heat waves that might ravage places in India like Jharkhand. And yet we never learn about these large-scale connections in space and time. So some of the lessons I learned that led me to developing and still developing a pedagogy of climate change are basically encapsulated on this slide. So climate breakdown spans vast scales of space and time that, you can have this slow rise of temperature from pre-industrial times through to today, to about 1 degree Celsius compared to pre-industrial time. And then you can have, a heat wave in Delhi for a few weeks that's made 30 times more likely due to climate change. So different scales of space and time. You can have climate change manifest differently in different places and affect people in different ways. The history of settler colonialism in Alaska, the history of British colonialism in India, and also the history of classic forms of discrimination on the basis of class and caste. All of these histories matter. And the two stories the second and third story that I told you illustrate that the climate crisis is inherently transdisciplinary. It cannot be seen in isolation from other things. You can see that all the disciplines are mixed in. There's history, there's environmental history, there's all the various kinds of sciences, from climate science to physics, chemistry, biology. There's economics, all of that. And the climate crisis, as I hope to point out a little later, is entangled with other major systemic problems like inequality and species extinction. And because they're complex interconnections in human and biophysical systems, the climate system is, of course, a complex system, and therefore simple linear causal ways of thinking don't really give us the kinds of insights that we need. So I'll visit that point also soon. One of the central aspects of climate is the issue of justice, because what the last two stories illustrate is that neither the native tribes of Alaska nor the village women of Jharkhand actually caused the crisis. And yet they are the ones who are impacted most by it. And not just that, justice appears in another form, in that these folks who are impacted the most often have good ideas and agency and creativity, which is never acknowledged. They never get a seat at the table. Their experiences do not generally inform policy. So the question is then, if I summarize those key learnings from the climate problem and contrast that with how we are taught to think in modern industrial civilization. So the left-hand column is admittedly an oversimplification, but bear with me. I hope you'll recognize that it's a useful oversimplification. Our education system, for example, does not allow us to recognize complexity or complex systems, to work with complex systems, nor does it allow us to talk across disciplines. So poets do not talk to physicists, and sociologists don't necessarily talk to biologists, and so on. And we live in the kinds of power hierarchies that hide or conceal difference, or at least normalize difference, whereas justice is a central feature of the climate problem. So it's not a surprise that we need more than one dimension to really effectively teach climate change. And I'm not going to actually talk about my pedagogy and the details of it in this talk. I'm going to focus on the role of stories. If people are interested, I have a couple of chapters, including this one, in a open access volume from UNESCO on climate education that came out last year. So in any case, the next point I want to make, and again, I'm not going to go into many details, but like one of the questions I had to deal with is that if I'm teaching a course that's not in the earth sciences, teaching students who are, some of them are science majors, some of them are non-science majors, what are the essential things they need to know that are the essential grounding aspects of climate science, which are also transdisciplinary, which allow doorways into wider examinations? And there are three interrelated concepts centered on justice. And one of them I've alluded to through the idea of steady state and change, or balance and imbalance. And the other one I've also alluded to in the sense that things are connected across space and time through complex interconnections. And when you have a system that can go from a steady state to a state of change, then it has to pass through a transition region, which could be abrupt or gradual. And that is expressed in the idea of planetary boundaries, or which is now being the details are being worked out, and it's at its next stage. I just heard a talk by Johan Rockström 2 days ago, and they're, I think, now calling them Earth system boundaries for good reason. But anyway, not to go into details, but to summarize the 5 major subsystems, the natural subsystems of Earth's climate that Earth scientists talk about. Now, many people have proposed that we add human beings, so we add the anthroposphere, because human beings have become geological scale agents on the planet. Now, in our classroom, in my classrooms, what I do is I have students interrogate the term anthroposphere on the basis of the stories I've told you. And I've only told you 2 out of about 8 stories that I use. And essentially, because we know that not all humans are equally responsible or equally impacted by climate change. So we use the slightly less inaccurate term, modern industrial civilization, as the driver, one of the drivers or one of the subsystems of the Earth's climate. And so the centrality of climate justice and the notion of planetary boundaries or limits. So the big circle represents the Earth, but it also represents thresholds set by natural cycles to which we are indebted for a kind of safe space for diverse social ecological cultures. So these 3 large concepts or meta concepts are in this diagram. And the question I want to ask is that because regional level subsystems and biophysical and climatic phenomena are actually connected to each other, as this picture shows. So for instance, the melting, so now people are starting to like quantify these. The melting of the sea ice is connected to changes in ocean circulation that can actually enable the drying out of the Amazon rainforest. So you can think of all of these as having domino effects on each other. So change in one system can create changes through these teleconnections and other subsystems, potentially towards large systemic changes. And so when we do that, we go from a system of essential steady state to one of change on very short timescales. And we can see that we are, from this graph, that we are heading towards an Earth that humans have never known, because we appear on this graph somewhere between 300,000 to 200,000 years ago. And so all the changes in carbon dioxide concentrations before and until about the start of agriculture, perhaps, and definitely since the start of Industrial Revolution, all those earlier changes were caused through from natural causes, the so-called Milankovitch cycles and so on. And we see that there are stages where human activity, and really interrogating that, the activities of what I'm now calling modern industrial civilization, actually accelerate that from the start of the Industrial Revolution, and then in a very dramatic way, the great acceleration that is post-World War II, which is both quantitatively and qualitatively different from previous changes. And we see that the carbon dioxide levels in the atmosphere have gone up, and today they are somewhere around 415 parts per million. This is another diagram that shows that we are headed towards an Earth that we do not know and have never known. So I'm not going to spend too much time on these, but I do want to point out this picture is a demonstration of the Earth system boundaries, the planetary boundaries. And here's our safe operating space. Here are thresholds set by these so far 9 identified planetary boundaries. And the orange and red indicate thresholds that we have violated. These boundaries, by the way, are not independent of each other, so that violating even one can lead to cascading impacts on the others. And what this leads us to examine is, firstly, one of the big lessons from this framework is that climate is not the only problem we have on hand. If we have so many large social ecological problems, do they have common roots? So this leads us to think about common roots. And ultimately, we get to our socioeconomic systems and our models of understanding the world, which is the thesis of my talk today. And I'm going to put a little quote here from Barry Commoner, who anticipated much of what we are talking about several decades ago. So let me focus on the epistemological dimension and the meaning of stories in this context. And I'll try to keep some track of time here. So this is a famous painting by the mystic and poet William Blake of Isaac Newton. And it shows Newton looking at a scroll and measuring something. And then there's the mysterious universe all around him. Blake was a famous critic of Newton and Newton's ideas. And the interesting thing that I'm going to only have to gloss over because of lack of time is that the origins of my own field of physics, Newton's laws, the atomic materialism of Descartes, along with other historical forces like colonialism and imperialism and so on, has given rise to a way of constructing reality that I'm going to argue, and this is an oversimplification again, but it's useful, a way of constructing reality that has become globalized, which is the Newtonian mechanistic paradigm. So the essential analog of this paradigm is a clock. So you take a clock, you understand the gears and the springs, and you've understood the clock. So this mechanistic way of looking at the universe, not just clocks, but universe, as I'll demonstrate, is therefore essentially reductionist, because the relationships between the gears and springs and their functions are simple and clearly defined. So you understand the whole by understanding the parts. And therefore, this is also an atomistic system, and it's deterministic. In fact, the laws of Newton establish that you can, with a little bit of initial information, you can predict with remarkable certainty the behavior of a system. And also, this is impersonal because we are not connected with what we observe. So this way of looking at the universe is actually, physics moved beyond it when we realized that Newtonian physics, if you look at the XY plane here, which shows where the domain of validity of Newtonian physics, it really works pretty well, really remarkably well at our scale of things. But we know that it is actually an approximation of more accurate theories about the universe that also reveal the universe as being incredibly strange and much stranger than we could have imagined. What I've done is I've drawn a Z-axis here, where qualitatively I show a gradation from simple systems to complex systems. So I've extended this box to demonstrate that Newtonian physics works pretty well for simple systems, but even at our scale, it does not give us complete information about complex systems. Now, if this was just to do with physics, that would perhaps not be that big a deal, but the influence of the Newtonian paradigm is very wide-ranging. The notion of looking at the Earth as a machine, or I remember my old textbook in, I think, middle school that started with the human body is like a machine. I saw a planetarium show made in 2009 that talked about the Earth as a machine. Mainstream economic theories, their origins, actually, they suffer from a kind of physics envy. 1915, Yale University, first PhD thesis in economics, Irving Fisher. There's a very interesting table in which on one side, he has ideal gas molecules, the properties of ideal gas molecules. On the other side, he has the properties of a perfect economy with human beings substituting for the ideal gas molecules. All right. So the invention of the individual as an economic entity, the idea of homo economicus, all of that comes from a misappropriation of ideas from classical physics. And then there's social atomism. And then, of course, our very siloed education system where there's no cross-disciplinary crosstalk, let alone transdisciplinarity. So I'm going to go very quickly through this because I've mentioned complexity several times, but essentially just a quick, rough definition of a complex system as one that defies reductionism, as one in which the interacting parts can change their nature and function when their interactions change, which is why the interactions are just as important as the parts. So in the climate system, for example, I mentioned that the tundra can go from a carbon sink to a carbon source. So can the Amazon rainforest. So can the oceans. That doesn't happen in clocks. So for such a system, we invoke the Aristotelian dictum that the whole is greater than the sum of its parts. And the tragedy is that complex systems abound in our world, the human endocrine system, the human nervous system, ecosystems, the global climate, of course. And I'm just going to mention that complex systems, because of all these so there's simple linear causality, but in a complex system, you can have different kinds of causality. In fact, there's a scholar at the Harvard Graduate School of Education, Tina Grotzer, who identifies 6 kinds of causality in environmental systems. And the behavior is often not linear as a result, so that we can have sudden surprises and sudden shifts. So here's a really cool example of what I call paradigm blindness, which means applying the wrong paradigm to a particular problem. So this was, ecologists will be familiar with this. So here's an example of this kind of linear, simple causal thinking, that you have a malaria outbreak. Well, malaria is caused by mosquitoes, so you apply DDT, end of problem. And in fact, it did control malaria, but there were other impacts as well. Thatch roofs collapsed, and there was an outbreak of plague and typhus in these villages in Borneo. So later on, scientists put all the pieces together and found that there were all these other causal links, which Tina Grotzer calls domino causality. Okay, so this is just one really interesting example of different kinds of causality in complex systems. So now let's get back to stories, because that's my focus today. So stories can maintain or challenge paradigms. They're a double-edged sword. So in fact, there's a very interesting book written by a couple of scholars from, well, actually non-science realms, about narrative literacy. They talk about stories as ontological tools, stories that help us build our conception of reality. And they can help consolidate identities, national, religious, so on and so forth. They can reinforce norms, both implicitly and explicitly. And therefore, paradigms have dominant narratives in them. And if there's time later on, and if there's interest, we can talk about that. But as ontological tools, carefully curated stories can also help challenge dominant paradigms by showing multiple points of view, as you saw from the last two stories I told you, and also showcase alternative paradigms, alternative ways of knowing, immerse the reader or listener in an alternative reality, and enhance new understanding through causal sense-making. So in fact, I want to mention that there's a very interesting, what might be a narrative turn in climate science. So we know that, we can predict with a very, with high confidence levels, what's going to happen to global climate in different future scenarios. But it's extremely difficult to figure out what's going to happen at the local scale, because the uncertainties kind of cascade and become very large. So so we have this scenarios approach, which has been there for a long time, which ascribes different probabilities to different kinds of outcomes and so on and so forth. But now there's some very interesting work going on. I'm just going to mention these two examples because I don't have time to elaborate. There's storylining, there are climate risk narratives, and then there are a couple of others that I found through talking with climate scientists in the last month, which I think is really exciting. Now, the idea of thinking of science as story means that you, in a sense, you can think about non-humans as actors on the stage of the world, which we neglect. We neglect that in the humanities, for instance. The very term humanities implies that you're neglecting everything else, right? So my small contribution to bringing science as story in the classroom as part of education is to actually do performative, or what I call sometimes physics theater or climate theater in the classroom, which, however silly it might sound, is actually very serious, because there's a body of work on embodied learning and how that enhances learning, and how that interestingly breaks this paradigm in science teaching and learning that, and in the sciences in general, that there has to be a separation of subject and object, and instead takes us towards a more participant observer kind of role as we try to understand the non-human physical elements of the universe. So here's a couple of pictures of an experiment I did in 2019 in the Eastern Himalayas with a bunch of village kids, where they're acting out the greenhouse effect. So we need paradigm shifts in science, we need paradigm shifts in education, and paradigm shifts do happen, as the history of science tells us. And here are only two examples. So there's one I want to highlight before I finish, and I'm horribly conscious that I might be going beyond time. So let me do this quickly. So this is this graph that you've seen before of carbon dioxide atmospheric concentrations from almost 1 million years ago to 2008, when this graph was made. This is the way we think about time, linear time extending from past through present towards the future. And when we tell the history of the climate, then we need to know what went before, what's going to happen now. And if we don't do this or we don't do that, then we are staring at hell. And that's an important story to tell. And you can see here that if you couch it in different terms, this is actually the story of the Earth and its creatures, the human and the non-human. And that's important. This linear narrative is important, but there's a problem with it. The problem with it is that it is scary. And when the fear response is not worked through in the right way, when we respond from extreme fear, we know that in the individual, it disconnects the limbic system, disconnects us from the prefrontal cortex, and it reduces our ability to think clearly. But not just that, we see that we have a tendency, perhaps collectively, to give up agency to strongmen or totalitarian rulers or to experts or whoever. And that's problematic too, because we live in unequal hierarchies where there is a pyramid of power. So I want to give a shout out to an essay by indigenous scholar, Potawatomi scholar Kyle White at the University of Michigan, where he talks about time in a different way that connects with everything I've been talking about. There's an essay called Time as Kinship that is freely available on the internet, where he says, he talks about a different way of looking at time than linear time, different way of looking at climate history. He talks about the climate problem being a problem of changing and broken relationships. And he quotes several Native American storytellers telling the story of climate and of climatic changes through these broken relationships, through story, through the modification of traditional stories in some cases. So I just want to give a big shout out to this essay because it completely reorients how we think about the climate problem. Instead of going straight to techno fixes, we say, well, if the problem is about broken relationships, then we have to start by looking around us and seeing what are the relationships that are broken and how might we mend those relationships. So I'm not going to go into details, but one great example of that is the recent Swinomish tribe in the Northwest United States Climate Action Plan. So in summary, what can stories do? What do our best stories do? I'm just going to list all the things I've talked about. I'm going to come back to the mouse story at the end of this. That's my last slide. So the mouse story. We started with the story of the mouse who wanted to know the world and therefore went up to the tundra and was inside an overturned boot. And I haven't even talked about speculative fiction and the power of speculative futurism to take back our future from the power pyramid. But I want to imagine a slightly different twist to that, the end of that story. So suppose that the mouse, in the shoe, the overturned boot, pushed a little hard on one side of the shoe and the shoe fell over. What would happen? The mouse would find himself or herself on the open tundra, perhaps under a night sky full of stars. What would the mouse see? What new concepts, ideas, and paradigms might arise? And I'm going to stop there. I apologize if I took too much time. Thank you for your attention.
Thank you, Dr. Singh. I wish we could go on forever and ever. The talk got even more interesting towards the conclusion. We have several questions. We are not exactly in control of time. It does move in somewhat linear fashion. We have less than 10 minutes, but I do think we can take at least the first 4 questions. So if we may begin perhaps with the fourth, Ishan Diore. Of the 4 nodes in Dr. Singh's carbon cycle diagram, we have influence over carbon sources, carbon sinks, and how much solar energy the Earth absorbs. Can we control / influence how much energy Earth radiates away? So that's a question from physics. But perhaps you'd like to take that up first. Thank you.
Sure, quickly. And again, my apologies. So very quickly, controlling influence how much the Earth radiates away. Well, that's really through controlling how much we emit, because the amount of carbon dioxide in the atmosphere is what prevents the Earth from radiating out energy fast enough to balance the incoming energy from the sun. So that really is the only option we have.
Thank you. Bharat Punjabi, given that climate science is largely a branch of physics, to what extent do physicists accept the legitimacy and relevance of other disciplinary contributions to understanding of climate change?
Well, I can't speak for all physicists, but I do know that there are an increasing number of them who are really looking at other disciplines. And I attended a conference recently, which was a sustainability and innovation research conference where climate scientists, including some physicists, really admit that transdisciplinary understanding is essential for for climate action. So,
thank you.
Yes.
How many whales are hunted each winter?
I believe the quota is somewhere around 60 per year, something of that order.
And Kamini Gopal has another question on whether the forest in Jharkhand has grown and whether they have ownership rights beyond 200 hectares, which limits expansion.
They do not actually have ownership rights. And I don't actually know at this moment whether it's grown in extent. It's certainly grown in density and in the number of species that have returned. And you're right, it does limit expansion.
So I'm jumping to the last so that people who come in late don't get left out. An anonymous attendee asks, climate policy action is quite slower compared to the ravages caused by the changing climate. Would the world and governments ever be able to bring paradigm shift in their policy actions?
Well, that is an open question. I wish I had the answer. I think that one thing we can do, which is to pressure the world and the government through foregrounding the actions of indigenous people and local communities, but also through our own actions for pushing for climate policy that makes sense and for culture change that is also essential.
So there's a larger question from Joseph Mathai actually related to this. You use the term modern industrial civilization, but why should we use modern? He argues it's essentially a meaningless term. Alternately, can we not instead use overactive, overpolluting, exploitative production process?
Well, part of the rationale for using modern is really to foreground the fact that it was since World War II that we kind of modern industrial civilization actually started to extract and develop technology that was so detrimental to the ecosystem. But I am open to alternatives. So I'm, like I said, my pedagogy is a work in progress. So I'll certainly think about that point. Thank you.
So Ishan Diore raises a very fundamental question. Should we not avoid separating the anthroposphere from the biosphere?
Very, very important. And in fact, that's one of the, that's one of the limitations of that picture I showed you. And that's why I try to draw lines between each to show that these are simply, temporary divisions of the Earth's subsystems. If you ask different questions, then we have different subsystems that make sense. So the context matters. The context of the question determines how we draw those circles. So very good point. Thank you.
So Pareen Sachdeva raises a question which has larger implications about, it's written as quite a way to deem something sacred by believing it to be a sacrifice. So this idea of sacrifice and relationships to animals that are hunted, how do you view that in given present concerns?
Well, to deem something sacred by believing it to be a sacrifice. Well, what I didn't get a chance to do was to share a story that brings out the concept of collaborative reciprocity. Collaborative reciprocity is this idea of mutuality. So it's not simply that the Inupiat hunt the whale and say, oh, this is a sacrifice. That would be in a sense a kind of convenient excuse perhaps. But the fact that they respect the whale and that every part is used and that the whale is never overhunted is a way of giving back to the ecosystem that maintains it. And similarly, people who depend on the salmon in the Northwest United States have similar attitudes towards. They eat the salmon, but they also keep the ecosystem restored and they share the salmon with other species because they know that they have to give back to the salmon. And they're actually working on allowing, the warming waters affect salmon breeding grounds. So they're working on creating cool spots in the rivers for the salmons to breed. So collaborative reciprocity is an extremely important concept in these cultures.
So I'm going to use my prerogative as chair. I was struck by something because the subtitle here is Storying Climate Change. And one of the very significant works in environmental consciousness was the book Silent Spring by Rachel Carson. And it just struck me, many students here will know, we study this book a lot at Ashoka. The first chapter of that book is called A Fable for Tomorrow. And one of the points she tends to make, and particularly towards the end of the book and through it, is that she argues that nature is to be seen as an interconnected whole. And one quote from her book became very famous. I was just thinking back. It says, in nature, nothing stands alone. So do you think that storytelling and fables, because Carson's book is not only about birds, fish, insects, and plants, it's very much about people. And the famous chapter on bird deaths quoted a lot of letters by what were then not are now called housewives, they're today called homemakers. So, is storytelling going to be central to the search for new questions and new ways of perceiving these relationships?
Well, I believe so. I think that is a lot of potential in storytelling for communicating complex problems, but also learning from each other about these complex issues. And thank you for reminding me, because I need to reread Rachel Carson. She was a major influence in my teenage years. So yes, indeed, yes to everything you've said. I don't think I can add to that.
I do wish we could carry on for longer. This is not your first visit to Ashoka, but it's your first to 3CS. We hope this will be one of many such visits. And I want to thank everyone for coming out on what is actually a very punishing hot summer's day. We've had a very, very good turnout, and the links will be on the website. I want to thank Keshav Suryanarayana, my distinguished colleague Ian, and Professor Gautam Menon, who's unable to be here, and everyone else who has put in so much work to make today possible. And Dr. Singh, we hope you'll join us in person in our campus once things open up. Thank you so much. Goodbye.
Thank you. Thank you. This was a wonderful, wonderful session. And thank you for bearing with me. My gratitude to you all.
Our privilege. Bye. Thank you all.
Bye-bye.